Hi, I am Hazen Russell, and it is with considerable pleasure I am able to participate in this sixth open house for Southern Ontario Groundwater Geoscience and the first virtual event. Today, I am representing my colleagues at the GSC and collaborators to review the GSC Groundwater Geoscience work in Southern Ontario for 2020-2021. Overview talks are built on the efforts of many colleagues, and here I would like to acknowledge the GSC contributors, our university collaborators by organization, and the key private sector contributors and funding sources. Notable funding sources are Agriculture and Agri-Foods Canada, Nuclear Waste Management Organization, the City of Ottawa, and the Ontario Independent Energy Systems Operators. The abstract is here as a placeholder and available for you to read should anyone be interested in this presentation in the future. This talk is an overview of groundwater geoscience program studies taking place in Ontario during 2020-2021. It is structured in two distinct parts, work in Southern Ontario and that which is occurring in the Ottawa Valley. In each part, we will progress from more regional studies to local scale. The Geological Survey of Canada Groundwater Geoscience Program is the vehicle for addressing a broad range of groundwater studies across Canada. GSC staff work in provinces under the auspices of the Intergovernmental Geoscience Accord, which is with the respective provincial and territorial geological surveys, in this case, the Ontario Geological Survey. Groundwater geoscience work in Southern Ontario is focused on providing federal government support to the Great Lakes Water Quality Agreement and the Canada-Ontario Agreement on the Great Lakes. Great Lakes Basin Modeling. The United States Geological Survey is leading a collaborative study that is looking at closing the Great Lakes water budget with implicit inclusion of groundwater, and also attempting to isolate shoreline and near-shore aspects of the groundwater surface water interaction. The GSC is involved through the Southern Ontario Framework Development and GRACE studies. Work on upgrading the published 3D bedrock model is currently in year 2 of a 4-year project. Release of version 2 is planned for late winter and will include extensive QA/QC to formation picks, delineation of Lockport Group formations, and well picks east of the Lake Huron. Additional enhancements for this project cycle include confidence modeling, porosity analysis, and communication activities involving virtual reality visualization. A hydrostratigraphic framework and model classification is also in progress. Terry will talk about this later in the program. The Surficial Geology 3D model is in draft format, and with the Ontario Geological Survey, we are working towards publication, hopefully, optimistically, this year. It has been developed with a simplified regional stratigraphy and the critical data support provided by the OGS Surficial Stratigraphic Studies constrain the abundance of low-quality water well data. The Surficial Provincial Groundwater Monitoring Network wells have been reclassified stratigraphically and will be hard-coded into the model to ensure screens are identified in the correct units. We are continuing analysis of the fully coupled groundwater surface water model to better constrain groundwater contributions to the surface water system in 3 key areas: stream base flow, shoreline discharge, and lake bottom discharges. This analysis is also being used to support further GRACE analysis. John Crowley presented at a previous open house on his GRACE Mass-On solutions developed for Canada. In Southern Ontario, we are working on integration of this work with Provincial Groundwater Monitoring Network wells and output from the Southern Ontario groundwater model to constrain temporal and spatial aspects of this signal across a range of scales involving individual wells to the coarse resolution of the GRACE watershed solution. Following 4 years of data analysis, most of the results have been published for the regional subsurface geochemistry as GSC open files. We are advancing a regional analysis based on stratigraphic units and spatial distribution to assess the subsurface lithogeochemical signature for glacial sediments in Southern Ontario. From the perspective of the complete data set, the good news is that the geochemistry of the samples analyzed to date have not detected any anomalous geochemical signatures that might have negative impacts on groundwater quality. At York University, CanMed Energy, along with the university and other partners, are completing an aquifer thermal energy system study at the North York campus. Rita will present on this work later in the program. The GSC is contributing geophysical expertise to this study and a separate study at the adjacent TRCA site. To date, a seismic survey is being completed, and this spring, additional seismic and downhole geophysics data will be collected. The seismic survey will provide hydrostratigraphic architecture and better characterize subsurface heterogeneity to optimize borehole placement. André Pugin will review this work later in the program. Agriculture and Agri-Foods Canada has a project in the South Nation watershed focused on assessment of sustainable and resilient ecological goods and services for agro-ecosystems titled Environmental Change, One Health Observatory, or in short, ECO2. The GSC is working on the aquitard characterization of Champlain Sea muds in the basin, protection for underlying esker aquifers, and is supporting numeric modeling through hydrostratigraphic development. Later in the program, David Lapin will overview this project. Champlain Sea Aquitard Study, funded collaboratively with the City of Ottawa, the GSC is working on 2 boreholes with near continuous sampling using Shelby tubes. This work is focused in the Orleans area of Ottawa. It is supporting geotechnical and hydrogeological characterization. And in collaboration with Ottawa U, work is proceeding on a full suite of hydrogeological parameters. Mark Hinton will discuss later in the program. Methods development. A key mandate and objective of the Groundwater Geoscience program is methods development. Listed on this slide are the 7 top items currently being worked on in Ottawa. Much of this development is focused on geophysical approaches for stratigraphic architecture and aquifer heterogeneity. We highlight here work with the University of Guelph G360 group on BMR logging and 2 field laboratories in the Ottawa area. Borehole magnetic resonance logging has recently been downscaled from the petroleum industry tools to slim tools deployable in groundwater wells. BMR is providing in situ estimation of water content and partitioning of water content between 3 components, mobile, capillary, and bound, along with estimates of porosity and calculation of hydraulic conductivity, and offers exciting new opportunities for groundwater studies. The G360 group of Beth Parker maintains a borehole field laboratory on the university campus in Guelph. The cored boreholes intersect the Lockport group and terminates in the underlying Cabot Head Formation. With G360, we are working on improved analysis of BRM logging technology for groundwater applications, which later in the program Heather Crow will review. Field laboratories in Ottawa. In the Ottawa area to support geophysical methods development, but also to advance understanding of specific groundwater settings, 2 field laboratories are being enhanced. Bell's Corners is a long-term geophysical calibration facility that has been rejuvenated with an interest for groundwater. It intercepts both Precambrian and Paleozoic rocks and can provide insight into fracture flow and aquifer properties related to municipal water supply in the area. The Embrum Esker site is hosted to multiple geophysical data sets, hydraulic test data, and sedimentological data that can be used for refining various geophysical interpretations, but also is being used within a machine learning environment to provide enhanced hydrogeophysics analysis of aquifer and aquitard heterogeneity. So in summary, the Groundwater Geoscience program is continuing to advance work initiated in the 2014-2019 Southern Ontario project and consolidating numeric studies of groundwater surface water to support International Joint Commission Great Lakes Water Quality Agreement and the Canada-Ontario Great Lakes Agreement. Within the 2019-2024 Groundwater Geoscience program, a key objective is consolidation of 25 years of groundwater studies at the GSC. In the Ottawa area, the focus of work is on Champlain sea mud aquitards within the context of an area of intense agriculture and challenging geotechnical properties and landslide activity with urban development. Contact emails. If you want to follow up with any of the contributors to this talk, their respective email addresses are provided here.